Welcome back, everyone. On behalf of the Russell Sage Foundation, Alfred P. Sloan Foundation, and Princeton University, it's my pleasure to welcome you back to everyone here and on the live stream and at the partner locations. What we're going to do now is talk a little bit more about zero variable cost experiments and Music Lab. This is an experiment that I worked on. Then we'll have a coffee break and we'll have our guest speaker. So this talk is really about experiments at scale. So what is possible to do when you really increase what you're doing by a factor of 10 or 100 or 1,000. So you sometimes hear people take any word and put at scale at the end and act like it's a new thing. And sometimes I think that's a little silly, especially because I'm on the East Coast. So if I lived on the West Coast, then I would naturally do that all the time. But on the East Coast, we don't talk about scale so much. However, I do think there is something really different about doing, if you can increase the scale by a factor of 100, it really requires a new kind of thinking. Don't think about what you've done before and doing that just 100 times. Try to think of doing something different. And so what I want to do a little bit now is teach you about how to think about enabling that scale, and then I want to teach you a little bit about how to be careful with that scale, and how to use that capability responsibly. So this is a picture that I think is super important, and it's one that you'll see in a lot of parts of computational social science, not just experiments. It's thinking about how the cost of some research project scales as the number of participants increases. So you see for an experiment, there's a small amount of startup cost. This might be this fixed cost is like having space for a lab or things like that. And then for each participant, the costs go up by a fixed amount. So if you want to double your number of participants, you need to roughly double your cost. If you want to increase your participants by a factor of 10, you roughly need to increase your cost by a factor of 10. So this makes really large experiments very difficult. A lot of digital experiments have a very different cost structure, which is they have very high fixed cost, and then they have almost zero variable cost. So this means that for a lot of relatively small experiments, sometimes these digital techniques are not really worth it. You're not going to see a huge amount of gain in terms of cost savings. But for certain kinds of numbers of participation, for certain types of experiments, really the only way to do it is by going to a more digital system with this different cost scaling. So how is it that you can get this cost curve with zero variable cost? How do you think about designing an experiment to allow that? So you have to think about what are the main sources of variable cost, and usually those are two. One is staff time, and one is participant payment. So staff time is often like if you're running a lab experiment, they're usually grad students or undergrads in the lab manning that study. Those people have to be paid. And participant payment is for the people who are in the study. You need to give them some kind of compensation. It could be money, it could be chocolate, it could be anything, but it's usually something of value. So if you want to eliminate those sources of variable cost, you want to do automation to eliminate your staff time, and you want to design enjoyable experiments so that the participant payment costs you nothing. So I want to talk briefly about automation. How do you know if you've automated your experiment sufficiently? So a good rule of thumb is it should be able to run while you are asleep. So during the Music Lab experiment, it would run while I was sleeping, and that was awesome. So I would literally get up in the morning, go to the lab, go to the office, run an SQL command, and see how many people had been in the experiment while I was asleep. So if you can do that, you're going to be able to do a lot of things that are hard to do otherwise. So neither of these things is easy. It's not easy to fully automate the experiment, and it's not easy to design enjoyable experiments, but I think we can do a better job of these things I think a lot of the way we think about designing experiments comes from a different era, and if we adjust to this newer era, we can design different kinds of experiments. So I want to talk a little bit about Music Lab. So this was the study that we did. This was my dissertation. My advisor was Duncan Watts, and then this first paper was co-authored also with Peter Dodds. So we built this website, and the website was built by Peter Housel, who was a software engineer in our group. We built this website where people could come and download new music. They were presented with a list of 48 songs. Actually, let me talk a little bit about what the motivation for this experiment was before I talk about the plumbing of the experiment. So it was really motivated by things like Harry Potter. So Harry Potter, as we all know, was an incredibly successful book, sold millions of copies around the world, translated into more than 60 languages. So that incredible success might make you think that Harry Potter was somehow better than all other books. Or if not better, at least different than all other books. But yet, Harry Potter was rejected by 8 different publishers before it was finally picked up. And it seems like a strange combination that something that went on to become so successful was so hard to distinguish ahead of time. And it turns out that this is not specific to Harry Potter. I could have told you similar stories about hit TV shows like American Idol or movies like Star Wars. And in fact, there's a general pattern in the market for books, movies, music, works of art, and TV shows where we see 2 things simultaneously. One is huge variation in success. These are sometimes called winner-take-all markets or superstar markets. And at the same time, tremendous unpredictability of success. So which things will go on to become the superstars is very hard to predict, even for people whose only job it is to predict those things. And so this makes you wonder why we see these 2 things together that seem to be somewhat contradictory. And so what we argue is that both of these collective level patterns arise from the same individual level process of social influence. So if people are influenced by what other people are doing, you can imagine how that leads to a process of cumulative advantage, which leads to these superstars. Also, if people are influenced by what other people are doing, these kinds of popularity snowballs could form very differently depending on small differences at the beginning of the process. So imagine if we could rewind the world to the day that Harry Potter was first released and make 8 copies of the world and have them all evolve independently. So the question would be, would Harry Potter be popular in all 8 worlds, or it would be popular in one and not the others? So if it was indeed popular in all 8 worlds, then we would know that Harry Potter is good. We would have to believe that evidence. That's pretty strong evidence. But if Harry Potter was popular in one but not the others, then we might know that it's lucky. And so the challenge is that we only get to see one copy of the world. And it's very hard to know from this one copy what can be attributed to the skill of, or the characteristics of Harry Potter, and what should be attributed to just chance. It's like imagine you just see a roulette wheel roll once. You don't know if the same thing is going to happen each time or a different thing is going to happen. And so we can't take the world and rewind it and make these parallel copies. But we can create these sort of parallel histories online. So we created this website where people could come and download new music, and then we're able to create these parallel histories and see to what extent they evolve similarly or to what extent they evolve differently. So this is the website. People were presented with a list of 48 songs by up-and-coming but unknown artists. So that's an important part of this. So if there was up here Britney Spears or Justin Timberlake, who were popular around this time, people would already come into the experiment with lots of ideas about those people. So these are all bands that people had never heard of, or were very low popularity, but also hopefully high quality. And then the only information you have about them is the name of the song, the name of the band, and then the number of times that song had been downloaded. And those are real download counts that had been generated by prior participants in the experiment. So you click on a song, you have a chance to listen to it, it begins to stream, and you get a chance to rate it on a scale of 1 to 5 stars. Then afterwards, you have a chance to download the song. So in the way we set up the experiment, we tried to encourage people to think that we were very interested in this rating decision, but actually what we were very interested in was the decision to download it or not. And then you're back here and you could listen to as many songs as you wanted. So behind the scenes, what the subjects did not see was that they were randomly assigned to these conditions. So to be clear, they did know they were in an experiment. They did fill out a consent form. We actually very explicitly made it look like an experiment. We put Columbia University really big. We put music lab, like the lab part was really big, because in this particular setting, we thought that the fact that it was a scientific study added legitimacy to it. Around this time, speaking of temporal validity, downloading music was like a little bit of a gray area because of Napster, and there's a lot of illegal downloading happening. And so we thought this added a lot of credibility to say, we put the Columbia crown on there. So anyway, what participants did not know is they were randomly assigned into either a social influence condition, which is what you saw, or an independent condition. So that was just like what you saw, but there was no information about the popularity. So this allows us to see what happens when people are acting independently. And then second, in the social influence condition, we split people into one of these 8 parallel worlds. So you could think of this as like putting people in a room, and you can see what other people in your room have done, but not what people in the other rooms have done. And so then we can see to what extent these worlds, which have the same initial conditions, the exact same songs, and indistinguishable participants because of the random assignment, to what extent these worlds evolve different outcomes. And then we can compare those to the independent condition to see what's the effect of social influence on the shape of the popularity distribution. So we ran 2 versions of this. One, the version on your left with less social influence, and then the version on the right with more social influence. So the difference is, in one case, the songs are sorted by popularity in a single column. So in both cases, the information about popularity is available, but in the second experiment, it's much more salient. And so you can see through this change in the interface, we're able to manipulate an individual level process and make it stronger. And then the question is that going to have the effects that we predict at the aggregate level? So, so let's see what happened. So here are the results. So the x-axis here is the market share in the independent world. And we talk about that as a measure of the appeal of the song to this group of participants. So we say, if lots of people acting independently download this song, that means these people like this song. The y-axis is the market share in the social influence world. So the market share is the number of downloads for this song divided by the total number of downloads. And so I want to emphasize 2 patterns. Let's start first with experiment 2. So what you see is that as the market share in the independent world increases, that's the appeal of the songs, the range, let me just say one more thing. So for each song, there are 8 points on the y-axis. So the highest appeal song in experiment 2, I believe, was She Said by Parker Theory. And so there are 8 points on the y-axis for that one song. And that's the market share of She Said by Parker Theory in each of the 8 worlds. So what you see, a couple of things. The first pattern you see is that for any given song, a range of outcomes are possible. Sometimes that can be quite big. So we had one song, in one world, this song came in first. In another world, it came in 40th out of 48. This is exactly the same song competing against exactly the same other songs. Lisa? The question was, what's experiment 1 and what's experiment 2? Yes. So experiment 1 is the one with less social influence, and experiment 2 is the one with more social influence. So what happens is when we increase the amount of social influence, we get more unpredictability. The range of possible outcomes for these songs increases. So you can see the one way to measure the unpredictability is for any given song to look at how much, if we randomly choose a song and we randomly choose 2 worlds, how different are they going to be? That's a measure of the unpredictability. And that unpredictability cannot be resolved by knowing more about the song. Because this is, again, exactly the same song, and you can see a range of outcomes are possible. I want to call also your attention to the shape of the points in experiment 2. It looks like kind of like a cone. It like opens up as the quality increases. So while I was working on my dissertation, I got to meet with someone who was the head of research for NBC. This is a major media company in the US. And I was telling him about this experiment, and he looked at experiment 2 and he said, oh, I already knew that. And I was like, great, what did you know? And he said, well, I can predict failure, but I can't predict success. So I think that was a beautiful summary of that pattern. So for the songs with low appeal, they always do poorly, but as the appeal increases, the variability also increases. So you'll notice that I talk about unpredictability a lot, but it's not the case that these results are purely random. So if you average the success across the 8 worlds, you end up with something that's correlated with the appeal. You can predict failure, but you can't predict success. So that's a very small amount about what we learned from the experiment. Now I want to talk a little bit more about the design of the experiment and how it relates to zero variable cost. So imagine that instead of, what was the incentive for people in this experiment? It was for them to download free music. So that was great because that is actually the thing that we were studying. And that incentive also has zero variable cost. So there was a fixed cost in getting the music because we had to contact the bands and get their permission. But once we had their permission, we could run as many people as we wanted through this without any additional cost. So if we had been paying people instead of giving them free music, we wouldn't have had the good cost scaling that we did. So I want to emphasize also that zero variable cost is a means and not an end. So you don't want to think about zero variable cost just to do zero variable cost. You want to think about zero variable cost for what kinds of research it enables. And so in this case, like the unit of analysis we were interested in was the sort of collective history. So those required like 700, each one of these data points was generated by about 700 people. So in total, we did 4 experiments, and so we had 27,000 people. And this was only possible because of this zero variable cost. And doing the experiments where the group outcome is the unit of analysis requires this kind of large number of participants. So let me try to explain that a little bit more. So sometimes people ask me like, well, what is sociology? And I'm sure some of you have had this question. Yeah, so what I usually say is, so in the same way that psychology is a study of individuals, sociology is a study of groups. And there are certain things that happen when you have groups of people that don't happen when you have individual people. And so it's kind of like the difference between studying a dog and studying a pack of dogs. And so there are certain things about packs of dogs you can't study just from an individual dog. Or the difference between juries and jury members. And so if you want to study juries and not jury members, then you need many juries. You need many groups. And so then you very quickly need very, very large numbers of participants to do experimental work. So in sociology, experimental work is not very common. And I think part of that is because we are often interested in group dynamics, and group dynamics are hard to study experimentally unless you have very large numbers of participants, and that used to be very difficult in the past. And I think that is becoming less difficult in the future. And as you'll hear about from Abdullah, it's becoming less difficult than it was yesterday even. Like he's actively working to make it much, much easier in the future. So it's a means to an end. The end is studying group dynamics. It's not something you want to do just for itself. Are there any questions about how we like set up the study or anything like that that people want to hear about? Yeah?
Kartik from the Boston location wanted to know how long the experiment ran for.
So in the paper, we report the exact dates because I was concerned about temporal validity. The answer is experiments 1 and 2 ran for roughly 3 months. And then there were 2 more experiments, which I didn't tell you about, that ran for also about 3 months. The key thing that determined how long they ran was how many participants we could recruit. So I didn't say how we recruited the participants. So we recruited them in experiments 1 and 2. There were ads on a website called bolt.com, which was like, is kind of like a early version of Facebook. And they wanted to be friends with my advisor, or my advisor wanted to be friends with them. I don't know, there was a collaboration sort of. And they had leftover ad impressions. They had not sold all their ad impressions. And so whenever they had leftover ad impressions, they would run our ads. And so through that, we were able to recruit 14,000 people, mostly American teenagers. And that 14,000 recruitment is actual registered. So we had many more people come and then not register. So I think when people think about recruiting participants, they often think, oh, let's just go to MTurk. But at the same time, we now have the capability to put ads anywhere on the web and recruit very different kinds of participants if we want to think about. So for example, you could run ads on the New York Times and recruit a bunch of people. Then you could run ads on the Wall Street Journal and recruit a bunch of people and see if you get the same kinds of results. You could run ads on Breitbart and see if you get the same kinds of results. So this capability, I think, of using ads to recruit people is one I don't see utilized very often. And our ability to target very specific populations with ads will only improve. So the length of time that we were able to recruit participants is what determines kind of how long they ran. Any other questions? Mm-hmm. Tom.
Just trying to understand the motivations of the participants. Like, are they really trying to go to the experiment to download the popular music that is already in the market? Like, just they don't want to download it free by payment, so they come to your experiment and download it.
Yeah, so what are the participants doing here? It's a good question. So I think what they were doing is a mixture of things. So one is they were looking to discover new music. And so they were not, when they participated, we told them this is going to be new music from up and coming artists. So I think these are people who are more inclined to want to discover new music. Also, we told them that this was a scientific study. And so some of the people were particularly interested in helping science. So there was also a big difference between experiments 1 and 2 used mostly these American teenagers that were recruited with ads. Experiments 3 and 4 used a very different population. So they were people who had participated in an earlier online experiment that my colleagues had done called the Electronic Small World Experiment. And so we had about 100,000 email addresses from that. And we emailed those people. And those people were older and more international and were people who had been in a previous scientific study and chose to respond to an email to ask them to be in a different scientific study. And so that was actually useful that these populations were somewhat different, because we saw, for example, in experiments 3 and 4, people would listen to more songs on average than the people in experiment 1 and 2. So that's like a parameter that determines the results that we did not control. That was controlled by the participants. So having participants who do kinds of different search behavior is important to see how robust these results are. So we found, for example, that the appeal of the songs in experiments 3 and 4 was different than in experiments 1 and 2. Like the older people liked different music than the younger people. But the overall shape of the popularity distributions were similar, and the overall amount of unpredictability was similar. but which particular song was in which particular slot was different. Yep.
I think there are also some interesting questions like how the recommendation systems or like micro-targeting shapes the collective taste of like music, or I think there are some studies on Spotify or like similar things. Like, do you know like what are the consensus and what are some open questions in these fields?
Sure. I think you're right that this has a lot of implications for recommendation systems. My sense is that it's very important for you to decide what the goal of the recommendation system is. And so one goal of the recommendation system would be that songs that are better, the popularity of the songs should be matched to their quality. That's like a goal of justice. A different goal is that people should be more likely to enjoy the songs that they listen to. And those two are actually quite different. So in experiment 2, I believe it's the case that people are more likely to download the songs that they listen to. But the relationship between popularity and success is actually weaker. So when you focus people's attention on a subset of the songs that are at the top are usually pretty good. And so if your goal is just to make sure people get exposed to good songs, then allowing these kinds of popularity snowballs and attention focusing is not necessarily a bad thing. But if your goal is to have a system that it's as fair as possible, then I think you want to, as much as possible, separate the popularity from what people actually, you want to separate seeing what's popular from actually engaging with the content. And I know there are a number of open questions about this for recommendation systems.
I actually had a quick question, which was, when you did this experiment, did you find that you had the fat head, long tail, or whatever it was, skinny tail as well? So there's a bunch of users who were using it a lot and a couple of people who just came in for a couple of songs?
Yes, so definitely there's a distribution in the number of listens per session, for sure, and the number of downloads per session. There are some people, especially the older people, who downloaded all the songs. And not that many, but a few. So yeah, we did see variation in behavior. And that, again, is kind of allowed because we're not really controlling what people do when they get here. So that also illustrates another key parameter that we fixed is the number of songs. So ideally, I would have liked to have had 48,000 songs, not 48, because I think that is a key element of the markets that we talked about, which is choice overload. There's just too many songs, movies, music, books, all these things. We ended up with 48 because that was the most that we could fit on one screen without scrolling. But you can imagine increasing the number of songs. You could also imagine changing the distribution of appeal of the songs. So if the songs were more similar in appeal, I think these effects might have been bigger. If there were some songs that really stood out from the others, I think the effects might have been smaller. So that distribution of appeal is another key system parameter that in this case was set by the place that we sampled the music from, not by some choice that we explicitly made. Yeah, Tom?
All right, so Chris from Mexico asks, how many different music genres did you add in the experiment? Because if you had, for example, 10 rock songs and 5 pop songs, it's possible that this may bias the results given the music preferences of the population.
Yep. So the answer is the distribution of genres was determined by the website that we sampled from. So we sampled the music from this website called purevolume.com. So there are a mix of genres. But one thing I want to clarify is this. So we don't make any statements about the quality of these songs in some kind of absolute sense, because I don't think that really exists. So like if you like Britney Spears, and well, let's say I like Britney Spears and you like Beethoven, you might say Beethoven is better than Britney Spears, but like, what if I say Britney Spears is better than Beethoven? Like, yeah. That could be. So what we like to do is we like to think about think that basically people like stuff. People like some stuff. Some people like other stuff. That's okay. And so what we are able to do is, because our participants are randomly assigned into the independent condition, we have a measure of the appeal of these songs to these participants. And then we have a measure of what their success is for indistinguishable participants. So I think this is one of the aspects of the design that I think was really helpful, is that prior research in this area had tried to measure the quality of the artistic products by critical reviews or other kinds of things like that. And there's always the concern that these measures of quality aren't the right measures of quality. And so here we say, we're not going to measure the quality, we're just going to measure how much these people like it. Okay, next. Okay. Victoria?
Anyhow, when you published on this work, did you also publish like descriptive things, or did you only publish on like causal things?
We published descriptive things like who was in the experiment and stuff like that. But the main thing we were interested in was these comparisons across conditions.
I have a question about mechanism. So what I found that, like, when you're comparing the two types of data earlier, in the earlier slide, can you go back to slide? Data points, like, yeah, that one. So experiment 1 is independent, experiment 2 is both independent?
Oh, sorry. Experiment 1 is less social influence, experiment 2 is more social influence.
Yeah, more social influence. So when I think about social influence over time, I think there are two mechanisms. One is a positive feedback mechanism and the other is negative feedback mechanism. What I'm saying is, I mean, when people are interacting, they could be positive, like everyone loving the genre, the music, and then the other one is same homogeneous group, but more negative. So depending on which mechanism is going on, it can yield to different outcomes, right?
Yep.
So I think if that's what's happening, and the two mechanisms happening simultaneously, then you're going to get more variation in the outcome, right? Because one is leading to different, I mean, they are leading to different equilibrium. So I wonder whether you have some evidence for that from your data, or have you some speculations or some theories or findings in the data?
Yeah, so a couple things. One is the kinds of things that can happen here are relatively small. So people don't know who these other people are. So for example, a lot of the kinds of boomerang effects and identity effects, like, oh, we don't want to listen to the thing as long as those people listen, that's not possible, because the only information you get is the aggregated download count. And then what we see, which I haven't shown you, is individuals are much more likely to listen to songs that are very popular. But then we don't see strong evidence that they are more likely to download a song when it is popular. So I have, in my mind, there's a relatively simple model of what is happening here, which is there's two decisions, really: what you listen to and then the probability of download given listen. Most of the social influence happens in the first step, what you choose to listen to, even though when people think about social influence in cultural markets, they often think about the second step. So that's what I think is happening. And subsequent to this, some people have built agent-based models that have a structure kind of like that structure that can reproduce the results of the experiment pretty well. So I'm just going to check the time because I want to make sure we have a break before our speaker. Okay? Katie? Okay, good. So let me just say I've taught you all about how to do zero variable cost experiments, and then I just want to remind you of something about zero variable cost experiments. So imagine you got an email like this. Dear Professor Salganik, I'm writing you because I'm a prospective PhD student with considerable interest in your research. I would like to talk to you today. Sincerely, Carlos Lopez. So since many of us are social scientists, we might have a guess about what is going on here. This actually was not an email I received. It was part of an experiment about measuring discrimination. And so the goals here, I think, are very good to try to measure whether academics are more responsive to people with different characteristics and whether it varies as a function. So they have many different types of names, signaling, identity signaling with names. And then they also try to separate short-term versus long-term responsiveness. So in this email, it says, if you would be willing to meet today, and they have others that say, if you would be willing to meet in a week. So this has a lot of good zero variable cost properties, right? So sending out emails, basically free. Recruiting participants, you basically just scrape a bunch of websites. Randomization is free. Measuring the outcome is also pretty cheap because they just reply to you or they don't reply to you. So I want to be clear, though, about what are the costs in this experiment. So in the way that I've described it, I've only described the cost to me as the experimenter, right? So I've said, how long does it take me to get the email addresses? How long does it take me to send the emails? How long does it take me to track the responses? And there's an important group of people whose time is not being counted, and that is the participants, right? So there is a very important difference between zero variable cost and zero variable cost to you. If your experiment involves hijacking other people's time, that is a cost that you should include in how you think about your experiment. So I want to just be really clear about that. So in the music experiment, we were not hijacking their time. They came to listen to music. If you're going to do an experiment that involves hijacking people's time, then please be considerate of their time. I think in this particular study, they were pretty considerate. They're important research goals in the same way that audit studies of discrimination are important because of other problems with other techniques and so on. I think this study is a reasonable thing to do, but please be careful about using, thinking about the cost of everyone, not just for you. Yeah, Victoria?
How are you defining hijacking time? Because if somebody is spending time on your website and you're like seeing how long they spend on your website, like
Sure. So what I mean by hijacking time is this person did not choose to be in this experiment. If I got this email, I have not opted in to participate in this study. So that is, I guess, what I mean. Whereas if you come to the music website, you're opting in to come and listen. Okay? So any questions about zero variable cost experiments? Yeah, Andrew?
I'm just wondering about the sort of
Yeah.
So when conducting an audit experiment, I'm wondering about the sort of relative position of the people that you may be contacting. So maybe an example here might be academics versus just elected officials.
Mm-hmm. Yeah, so I think one of the reasons that I, for example, heard about this study was they contacted a lot of professors, and professors like to talk to each other. And so when professors found out they were in the study, some of them were unhappy because they said, I was a participant in this experiment and I wasn't compensated for my time. So I think you're right that I think it's as a practical matter, when you're doing experiments with participants who have a lot of power, you have to be careful. Ideally, we would be careful and respectful of all of our participants, which is what we should do. Maybe a good way of thinking about it is, would I do this experiment if the participants were powerful politicians or powerful professors or other things? And if the answer is no, then probably you shouldn't do it if it's other people. But yeah, I think as a practical matter, it's an issue who the people are that you're doing your research on. All right, so I'm going to take a moment to bring the next speaker up and get the laptop connected. So let's take a 5-minute break. We'll come back and hear Abdullah talk about high throughput experiments.